This video is for section 4.6, and this is the third video or the third part of this lesson. So we have been solving, and in section 4.6 we have complex or imaginary roots. So we've did solving by greatest common factor, and we've done solving by grouping. And starting on page 4, example I here, these are not greatest common factor and not grouping. If you look, we have 3 terms, and we have an even degree and no greatest common factor. So these are what you guys might call X box or X or quadratic form. They're kind of a quadratic form. So we just need to remember, because we have x to the 4th, our factors are going to be x squared and x squared. So if you're doing the x method, a times c, a is 1, b is 13, c is c. So a times c is 36, and b is 13. So I'm looking for 2 numbers that multiply to give me 36 and add to give me 13, and that would be 9 and 4. So my factors are going to be x squared. Everything's positive here, which makes it nice. X squared plus 4 and x squared plus 9. And remember, equals 0. All I'm doing is writing this in a different form, so I will include the equal 0. So now I have 2 factors. Multiplied together equals 0. So that means one or both of them must equal 0. We're going to set both of them equal to 0 and solve those 2 equations for x. So I'm going to subtract 9 from both sides, and I'm going to have x squared equals negative 9. I'm just going to keep going with this one. To get rid of a power of 2, I'm going to square root both sides, and I'm going to have x equals plus or minus the square root of negative 9. So remember, this is the same as square root of negative 1 times the square root of negative 9. So the square root of negative 1, let's put this at the top of our paper again, square root of negative 1 equals I all the time. So this is going to be square root of negative 1 is going to get me I. Square root, oops, this should be positive 9. Sorry about that, because I broke it into negative 1 times 9. Square root of 9, that's a perfect square. It's just 3. And again, we want to write number in front, I, treat it like a variable, write it behind. So that's 2 of my solutions. Now, don't forget about this one. We have to finish this one. So minus 4 from both sides, which is going to get me x squared equals negative 4. And then I'm going to square root both sides. So I'm going to get x equals plus or minus. Whenever you're square rooting both sides, you're going to need plus and minus. This is the same as negative 1 times positive 4, both still in the square root. I have not taken the square root yet. That's going to get me x equals plus or minus square root of negative 1 is I. Square root of 4 is 2. So my other 2 solutions are plus or minus 2i. So this step right here, very similar to what we had in the last 2 videos. Only thing different here is how we're factoring. Okay, so same thing, 3 terms, even degree, no greatest common factor. We want to think our x method. And so what I would end up here is x squared, remember, because this is x to the 4th, we're going to have x squared plus 4. X squared minus 1 equals 0. I'm not going to go through this whole x method here. You can do that on your own. You've had plenty of practice on that. So now set both your factors equal to 0 and solve. Remember, if I'm ever going too fast, all I got to do is pause and rewind the video. Minus 4 from both sides to get the x squared alone. X squared equals negative 4. Square root both sides. So x is going to equal, the negative 1 will simplify to an I, and the square root of 4 is 2. So this is going to be plus or minus 2i. So I'm skipping a couple of steps here, but I'm thinking probably after all these examples, most of you have the idea. Whenever you have a negative under the square root, You're going to have an I in your answer, and then take the square root of the number without the negative. So the square root of 4 is 2. Whenever I square root both sides, add the plus or minus. Okay, let's do this one. Add 1 to both sides. So x squared equals 1. Square root to get rid of the power of 2. So I get x, not x squared. I'm even going too fast here for myself. X equals plus or minus square root of 1. No negative under there this time. So the square root of 1 is 1. So this is just going to be plus or minus 1. So these are 2 real roots, and these are 2 complex or imaginary roots. So if you graphed that, the only solutions that would look like x-intercepts would be the plus or minus 1. Okay, what's happening in K here? Well, the first thing I notice is this should be equal 0, and it's not. So if I want a 0 over here, I want to subtract 24 from both sides. So then I'm going to have equals 0. And on the left, I'm going to have x to the 4th minus 2x squared minus 24. So I'm looking for factors of 24 that subtract to give me 2. Those are going to be 6 and 4. And remember, if you need to, draw your box. It's going to be 6 and 4, and the 6 is going to need to be negative. So I'm going to have x squared minus 6 times x squared plus 4. Those two quantities equal 0, so separate them into 2 separate equations and solve for x. So add 6 to both sides. X squared equals 6. I'm running out of room here. Square root both sides. I'm going to go this way. So x is going to equal plus or minus. Now 6 doesn't look like one that's on my perfect square list. And if I put this in my calculator, square root of 6, I get a decimal. So I'm just going to leave this as plus or minus the square root of 6. Remember, that's actually more accurate than the decimal. Okay, let's finish this one. So minus 4 from both sides. So I'm going to get x squared equals negative 4. Square root both sides. So I'm going to get x equals plus or minus the square root of negative 4. Whenever I have a square root with a negative underneath, the negative is going to come out as I, and the square root of 4 is 2. So this is going to be plus or minus 2i. So again, this one has 2 complex roots. They're right here. These will not be x-intercepts. And 2 real roots. These will be x-intercepts. They'll be decimals, but that's fine. Okay, example L, I am going to leave for you to try. I will tell you that you should get plus or minus 3 and plus or minus 1. So both of these, or I should say all 4 of these, are real roots, real solutions. So if you graphed this, you would see 4 x-intercepts. 1 at positive 3, 1 at negative 3, 1 at positive 1, 1 at negative 1. Let's look at this last one together. Because it looks a little different. The one thing you might want to say to yourself is that 256 a perfect square? And if I already did it, I put 256 in my calculator, and 16 times 16 is 256. But let's go ahead and do x on this. So my a is 1. I don't have a b, so that's 0. And my c is negative 256. So 2 numbers that multiply to get me 256 and add to get me 0 are going to be 16 and negative 16. So I'm going to factor this into x squared plus 16 times x squared minus 16 equals 0. and then set both of these factors equal to 0. So over here I'm going to minus 16 from both sides, and I get x squared equals negative 16. And then I'm going to square root both sides, and I'm going to get x equals plus or minus, the negative will become I, and the square root of 16 is 4. So this is plus or minus 4i. So that's 2 complex roots right there. This one, I'm going to add 16 to both sides. So I'm going to get x squared equals positive 16. Still going to square root to get rid of that power of 2. So I'm going to get x equals plus or minus, no negative this time, so it's not complex. I don't need an imaginary number, just 4. So these are 2 real roots. So they look very similar. These will not be x-intercepts, these will be x-intercepts. I think I'm going to end that video here, and the very last video for 4-6 will be when we're writing our equations. So that'll come in the next video.